Hi, this is Nathan,
And I'm Grayden.
and today we're going to be explaining standard atomic notation, which is basically the standard atomic notation is basically one way of showing the electron, an element, basically. Today we chose silicon, and we're going to be showing you how to perform standard atomic notation with an element.
Yeah, easily right from a periodic table entry, which I've hand-drawn one here.
So, first off, you're going to need the atomic symbol, which we've already got here, Si, silicon. Now, looking at this rough drawn picture here, we can now base our standard atomic notation easily. Now, it's fairly similar to this, only for the most part, we need to put the numbers in slightly different places. So let's start off with the atomic number.
Atomic number is the number of protons in it. It is usually on the top of most of the periodic tables I've seen, and it actually goes on the bottom of standard atomic notation. So I put 14 down here instead of up there.
And then the mass number, well, we have it here, and it's 28.8. So basically, we're going to round that out to 28, and we're going to get it here. And yeah, there you go.
Yeah, just to repeat it, this is the atomic number, and this is the mass number. You got to remember that.
So that's basically all of it. All
Yes.
you need is the atomic symbol, the atomic number, and the mass number.
Yes. Normally, the bigger number or the mass number is on top, and the atomic number is on bottom. That's how you do it.
So just remember this, and I hope this answered all questions about standard atomic notation. Hi, this is Nathan,
And I'm Grayden.
and today we're going to be explaining the Bohr-Rutherford diagram, which, if you can tell by the title, was made by two scientists, Bohr and Rutherford, or their last names. So that's just a basic fact I wanted to start out with, so we all understood why it was called that. Now, basically, this is a diagram to show the easiest way to explain a nucleus.
And the rest of the atom, yes.
Granted, this is not what a nucleus and atom would actually look like. Just to clarify, this is just the easiest way to explain it. So, for this, we're going to see, as you can notice right here, by our basic outline of what it should look like, we need to know the number of protons and the number of neutrons. We're also going to need to know the number of electrons to draw into the diagram. So,
for this, we're going to be using silicone again. So, using a cool thing that we use, we do pen. That is protons, electrons, and neutrons. And then you can use that to write in how much protons, electrons, and neutrons your thing has. Silicon has 14 of each.
You can tell this by the atomic number, and electrons will be the same as protons. Now, neutrons you can find by subtracting the mass number, which was 28, subtracting the number of protons or electrons.
No, yes, mass number by proton. Subtract protons.
You subtract that from the mass number, 28, and you get 14 in this case. So now that we know this, we can continue with the Bohr-Rutherford diagram.
Yeah, you put 14 here for the protons and neutrons. They're inside the nucleus. And then now we work on the outside. So I'm just going to change my pen tip smaller. And one thing you got to know, this first little orbit closest can only hold 2 electrons.
And then every other ring should be able to hold 8.
Yes.
Granted, you should not use more rings than you have to, and there's a certain limit when you can't use more rings.
Yeah, once you get past around element 18, it gets too hard to do the Bohr-Rutherford diagram.
So keep that in mind when doing this.
Okay, and also, you should go in quadrants, each corner, when you're starting to do your electrons. So, like I'm doing.
That is the best pattern because that's how it should look. That way, if you have one left over, then it should still match the pattern.
This will also help later on. So here we have 10 on the inside and 4 on the outside, 14. Yeah, I know that doesn't really look like one, but it is. And this is how you draw a Bohr-Rutherford diagram. This thing can be used for a few other things later, but we're not explaining those at the moment.
Yes, this will be very helpful for another type of diagram that we'll explain soon.
Yes.
I don't think there's anything else that we need to clarify. I think this should very well explain it. Okay, I hope this was educational.
Yeah, one last thing to say. This is very helpful. Protons, electrons, neutrons. It makes it very easy to organize your work and put it into this really easily.
Yes, very important thing, gathering your information this way.
Thanks for watching. Hello, this is Grayden,
And this is Nathan.
and we're going to be explaining the electron dot diagram. Oops, didn't mean to try that.
So to start off, we're going to need the atomic symbol, which we've gotten because we're using silicon. So it's going to be Si. One thing that I realized we haven't made clear before that we should have by now, when doing the atomic symbol, make sure that you only do the first letter capital, and the second letter is always lowercase.
Okay, so to start off with this, we can use something that we actually did before. This is a hand-drawn Bohr-Rutherford diagram, which we would have explained to you before.
This is probably the easiest way to clarify to do the electron dot diagram. There are other ways that you can do by using equations.
Okay,
Granted-
this diagram's wrong. You messed up. You got 15 electrons. There's only supposed to be 14.
You're right, I did, and that's why I tried to scribble that out.
Oh, I see. Okay.
So now we're gonna use this basically. My
That one's gone.
Bohr-drawn.
That one's not right.
Yeah, my Bohr-drawn Bohr-Rutherford diagram, and now
Okay. Oh, what?
basically gonna use the outermost orbit or the valence electrons to base our electron dot diagram on. So you'll notice that if you ignore that little scribble there, I put 4 on every side.
So you do that.
Or
Here,
1.
too.
Yeah. So we copy this.
You're doing the electron dot diagram. You're just copying the valence electrons.
Yes. And that's pretty much all there is to the electron dot diagram. There's not much else. There is other ways to do this. However, this is the most easy, efficient way. So we recommend this more than doing all the math that would require to do it the other way. So yeah, that's all.
Well, it's the fastest if you're doing a Bohr-Rutherford diagram. And like we do that most of the time when we're talking about adding elements and stuff like that. So if you do that too, this is the fastest way to do it.
Yeah. Just remember, it's always easier when you've collected your information first.
Yes.
Okay. I don't think there's anything else we need to clarify. Graham, do you have anything you need to clarify?
No, we've pretty much got it all done.
Okay.
Just remember,
Oh,
the quadrants are the same as on the diagram.
okay.
Okay, bye.